Common problems I saw in the flowchart were we had a place where we said while correct equals false, right? Something like that. Or maybe we did it a little bit differently. Some people had a slightly different while loop there, and so your logic must have followed that in your code. That's okay. But while correct is equal to false, nothing ever set correct equal to true. So that'd be an infinite loop. What your nested loop is going to pretty much look like is you got some stuff up here, right, setting up the loop, however so, and then we have the while here, and then it runs off over here, does some more stuff, gets some input maybe, and then it has some whiles underneath there, right? And the while branches off, and if it's true, it does something, I don't know what, and then it comes back. And if the decision was false, well, then it either went straight back down or it went to the other side. But I'm just going to draw it as going straight down like that. Pretend that that's a little circle. It wasn't letting me choose one. Guess I could always change the shape. All right. Anyways, oh, for Pete's sake. So then they joined up again, and then there was another decision block underneath that, and maybe a third. Right, did something else, come down here, did something else. You know, and some people's guessing games looked a little bit different than others, or their logic did, but as long as I looked at it and go, yeah, that's the logic for a guessing game, then you got a lot of credit. But, yeah, see if I can get to the point where I saw some weirdness. Right, that's the while loop stuff. And then it comes back together like that, and then maybe it prints a message, you know, saying done. And then there was finally, you know, a stop at the bottom. Right, something like that. Now some people take the my comment saying that the lines can go anywhere a little too much to heart. And so they wander off to the side, and then they wander off to the other side, and it makes it very difficult for me to follow the logic. It doesn't mean the logic is wrong. And so if I stared at it long enough, quite commonly, I was able to get it. For some folks, I drew on your flowchart. I took a screenshot and drew on it. On other folks, I just said there's dead ends or something like that. So that's a problem. If this goes over here, and then there's no rejoining there, that's kind of a dead end. If you have multiple things going to the terminator or to the last statement, like this, then there's no way that that's good logic. Your nested while and ifs is pretty much going to look like this. And you know, this code is not complete, and maybe there'll be stuff like that. There's no such thing as an else block. So don't put a diamond there and say else. Make sure that your ifs loop back together as soon as possible. Elifs are a little bit weird, and so I've decided to stop trying to ask you to flowchart programs that have elifs. In those cases, they can wait until the very bottom to hook back up, so I didn't count off, I don't think, if you did it that way. But hopefully, if I did give you a sample, a correction, that it makes sense. If it doesn't, ask me for it. If I just wrote a comment without drawing the correction, then ask me for help. In one case, the code looked like this. That was missing. And so this went like that. Nothing ever looped back up to the top. And that's like a one-shot guessing game, right? They get one shot at it. If they got it right, great. If they didn't get it right, great. So you needed to put this chunk of code nested inside the while, right? And when I say nested, I mean shifted off to the right with a while loop here, and then it goes here, and then it loops back to the top. Hope that makes sense. So we are well on our way towards actually being done with the looping chapter by our knowledge. We are ahead in our knowledge compared to where we are in the PowerPoint. And that's okay. That's always my goal, so that when we come back. A for loop, we've talked about. You use a for loop when you want to either count a series of numbers or when you want to step through a series of values in an array. So, for a for loop, you specify a starting value, you specify an end value, and you specify a step. Now in our language, the syntax is a little bit different. You don't have to specify a starting value. And you use the range keyword. So for count in range, 0, comma, 3, but Python's a little bit different. We got to put 4 there if we want to go to 3. I'm sorry about that. There we go. That would do the same thing that the code said a minute ago. It would count 0, 1, 2, and 3. But we can leave off this thing if it's doing a step by 1. That's the step portion. But if it's going just by 1 every time, leave that off. If you're starting at 0, leave that off. Now you can't do this. You can't leave off the first one but then put the step, because then it thinks it's supposed to try to count from 4 to 1, and you can't do that. So the safest thing to do in Python is just to list explicitly all 3 components. I'm starting at 0, I'm going up until it hits 4, so it would be 0, 1, 2, and 3, and I want it to go by 1s. If you wanted to go from 1 to 100 counting by 2s, well, we'd actually want to start it at 2, right? And we'd want to put the last number 1 past it, so it would stop at 100, and we'd say do it by step 2. So that would count 2, 4, 6, 8, all the way up to 100. So your for loop initializes, your for loop does the comparison, and your for loop does the update all in one thing, which is everything that a while loop needs as well. It's just a nice clean syntax, so it's perfect for counting.
Oh, real quick question, one more time.
Yeah.
Make sure I
Yeah.
Are you saying the first number is how much you're counting by, or that's the starting?
That's the starting point. That's the initial value.
Okay.
This is the end value plus
That's the
1.
end value plus 1, you said?
Yeah. Or the value it's supposed to stop before it hits. Right. If you're counting from 1 to 10, you better make that 11.
So it'll include 10.
Exactly, because you want it to include 10, so you better put it as 11 if you want to count from 1 to 10.
Okay, and then the last number
Is how much it's skipping by each time. That's the step. You want to count by 3s, 3, 6, 9, 12, you better put a 3
okay.
there.
Okay.
Yep,
I
yep.
had a couple things transposed, but I got it now.
Okay,
Thank you.
yeah. I think you just had that and that one kind of swapped.
Right.
That was going to be the step, and it's not. Okay. So you can do just about everything you do with a for loop with a while loop, but the syntax takes several statements longer. It can take like 3 or 4 lines to express in a while loop what you can with 1 line of the for loop. So while loop is also a pretest loop. Pretest meaning that the check happens before it starts doing some code. We don't even have a do loop, which is a post-test loop. Post-test just means that the test happens after the body of the code is executed. That exists in some languages and it doesn't exist in ours. So this is more of a while loop or a for loop structure. And I always draw the line coming back underneath and hooking up with that, but they always draw it going above it. Either way is correct. So while and for loops are pretest because it does the test before it goes into the body. Just like an if statement, it has to do the if before it goes into the body. And then there's a do loop, which is a post-test loop, which means do the body and then do a test to see whether it's supposed to repeat. And we don't have that in our language, but if it's a quiz question, I won't ask about it on an exam since it's not in the language, but if there's a quiz question on MindTap about it, just remember that there's a post-test loop that looks like this. It's got the body, and then it's got the test underneath it. Comments worth adding to a file. I thought I had a Dropbox for Esme. Here we go. All right, so Lecture S. I want to finish loops today. Notes. So there are pre-test loops. The test happens before the body of the code. The test must succeed before the body of the code is executed. Body of the loop is executed. For example, while condition, do something. That's a pretest loop. Or for x in range, whatever, do something. That's also pretest. Both while and for are pretest loops. Not LOPOS loops. The book talks about post-test loops, which Python doesn't have. Doesn't mean that Python's broken, but it's acknowledgement of the fact that there's nothing you can write with a post-test loop that you can't write with a pre-test loop if you're very careful. So I don't talk about it much. In the languages that do support it, it looks like this. Do some block of code while condition, right? So it's going to do the block of code until the condition is false. So a so-called do loop is a post-test loop. And again, Python doesn't have those. Python only has while and for loops, not do loops. Seems to me like he could have, Mr. Python could have put it in there if he wanted to, but he chose not to. 20 years of the language has gone by without him, so obviously it's not necessary. And so if you're going to flowchart a pretest loop, you have your diamond, then you have a block of code off to the right, and then the line comes back up either above the diamond or back to the diamond. If it was a post test, you'd have some blocks of code, and then you'd have the diamond underneath it, and a line coming back up to above the block of code. You don't have to make those corrections. I'm just giving y'all extra time to type. So, an example of a post-test loop. Do, and our loop is pay a bill, while more bills remain to be paid. That's just kind of the opposite of saying while more bills remain to be paid, pay a bill. The only difference is that this assumes that it dictates that the body of the code will always be executed at least once. If we were looking at our code here, if this condition is false to begin with, it won't necessarily do that. If the for loop's condition is wrong, if we set up our for loop wrong, or it's counting through an empty list or something, then it won't do something at all. Pretest loops do not guarantee that the body of the loop will execute. That sounds bad. I don't want it to be guaranteed. No, sometimes you don't. What if the list is empty? You don't want it to do anything in the loop, right? A post-test loop guarantees there's nothing to stop it from doing that block of code. And in the circumstances where it's absolutely a must that the block of code get executed, at least one time, then you'd probably want to use a post-test loop if we had it in our language. Like I said, there's nothing you can write with a post-test loop that you can't write with a pre-test loop. So, a post-test loop, the body of the loop always executes at least once. A pre-test loop, the body of the loop might not execute at all. Which is okay, if it is okay. Which is probably okay, right? I mean, the logic that you're trying to follow dictates whether that's okay or not. Maybe I should change that to which is not necessarily a problem. Better not be a problem because it's all we've got in this language, which is not necessarily a problem. What if the file is empty? Then you're not going to process every line in the file, right? So you don't need to go into the while loop if the file was empty. What if the user enters -1 as their very first piece of data? Well, there's no reason to go into loop asking for test scores and calculating averages if they entered -1 right from the get-go. So, it's not necessarily a problem. What if the file was empty? There's no need to do something with each line in the file if there are no lines. There. That's talking way more about post-test loops than I'd like, but it's in the book. You'll see them if you work in Java, C++, JavaScript. You'll see them in other languages, and it's just not in Python. So all structured loops have these characteristics. The loop controlling structure is the only way into or out of the loop. What do I mean by that? If we go back to our flow chart, there's only one way into the loop. That statement. Well, I've messed it all up, right, because I was demonstrating a problem, so I deleted a bunch of stuff. Let's fix that. Here's your while statement. That's the only way into the body of the loop. That's why if you drew a line sneaking out of the loop or going, from here to, from here to here, something like that, right, then that's wrong, right, because there's showing a way out of the loop that doesn't involve the loop structure. Some languages have the do until loop, but whatever. That's just another form of post-test loop. So common loop applications, you can use a loop to accumulate totals. We're going to get a whole bunch of test scores, or we're going to open a file and read all of the data out of the file. So for examples, a business report often includes totals. All the real estate sold and their total value. And you have the accumulator that gathers those values. And surely we've done that. We've done summation loops. We've done summation loops for a long time, I think, right? Add all the numbers between 1 and 100, that kind of thing. We've probably done an add test scores kind of thing, right? Sounds familiar? Enter test scores, add them up. So above the loop, you had your accumulator, totals equal to 0. And then you had a while loop gathering data, updating the accumulator, updating the total. And then outside of the loop, at the bottom, underneath the loop, outside of the body, we print the total and the average or whatever. So if we're doing an accumulator, like add all the numbers between 1 and 100, you got to initialize the accumulator to 0. The accumulator needs to be modified, updated for every execution in the loop, right? We're going to add 1 to it, 2, 3, 4, and so on. And at the end of the processing, the accumulators are output. We print our total. And so summary report contains totals without the details. Right? That's what summaries are for. You're printing all the sales of every Quick Trip in the state. You don't want to see the sales for each and every Quick Trip. You want to see the total sales. And isn't it weird that there are no Quick Trips in Oklahoma City and there are no 7-Elevens in Tulsa? Those two companies have a gentleman's agreement not to intrude on each other's territory.
Isn't OnQ part of that too?
I don't know if there's if there's an agreement between OnQ and Quick Trip.
I thought there was.
That's very possible. So you can use a loop to validate data, also known as defensive programming. We have done defensive programming, a lecture on that, have we?
Yes, sir.
Yeah, okay, so defensive programming is just making sure that the user cannot enter bad data. You go into a loop until they give you good data. The month has to be between January and December, otherwise it's a big problem. Credit card has to have, exactly 16 digits, something like that. The expiration date of the credit card, it better not be before today. And garbage in, garbage out is just a phrase meaning that if you don't validate the input, then you're going to get bad output. So if you don't rule out garbage input, then your output's going to be wrong. This is saying that if you're trying to do defensive programming, you might give the user a way out. If they've entered a negative number 17 times in a row and you only wanted positive numbers, then maybe you ought to default to some value and just let them skip that. Now that sounds kind of stupid to me. But they're saying that you could maintain a count of the number of reprompts, right? And if we ask the same question 5 times in a row and they get it wrong every single time, then maybe we're just give them a default value, assume that they're too dumb to get it right, and go on. Now that assuming that they're too dumb bit seems like a problem to me. If we're entering a social security number and they can't manage to get that right, then that's a real problem. Not that people are supposed to use social security numbers for identification purposes anymore. A while back, your social security number was your driver's license number in Oklahoma. But then they passed a law saying that wasn't the case, so everybody got new driver's license numbers. So validating your data type, you should have some way of checking to see if it's numbers. And we've seen is digit, or is car, short for character. They say is char, it looks like up there, but it is character. Or is white space, or is upper. Now these aren't the names of our functions. Our functions are called is alpha to see if it's an alphabet character, or is white to see if it's a white space. So white space is just tab or the space bar. Or is upper, all lowercase. But the same idea is fine. And is digit, those are the functions in Python, but same idea. So typically what we do when we're doing that kind of stuff, and this language forces us to do it, is accept the user data as a string and then we convert it to the correct data type. Some languages have a facility for reading in a number directly. C++ and Java, you can say, okay, I know a number's coming in and I want it to be treated as an int. You don't have to do that conversion step, x equals float x, anything like that in those languages. We need them. We need them in this language. So you validate the reasonableness and the consistency. Many data items can be checked for reasonableness. Don't allow negative prices to be entered, stuff like that. Good defensive programming means you try to foresee the mistakes that the user can make. They might try to skip entering a name. They might try to enter only one character as a name or a period as a name or something like that. You can rule that out. You can try to make sure that they have a good name. I don't know what the rules for names ought to be, but they probably ought to be letters, or at least start with a letter. I've never seen a name that started with a number, and be more than one character long. And I'm sure that, in some languages you might have a name that's only 2 characters long. And most people have first and last names, except for Slash and Madonna. I'm kidding. I wonder how they fill out their bank account forms and stuff like that. I know Madonna has a last name. I can't, anyways, you get the idea. So our summary. The loop must write once. Why do you use a loop? So you can have one set of instructions that operate on multiple separate sets of data. Every loop pretty much has these three things in it. You initialize a loop control variable. You compare the variable to some other value and you alter it. Initialize it, set x equal to 0, or set, your guess equal to input, something like that. You compare the value to another variable. If x is greater than 10, it's time to stop or whatever, and you alter the variable. You let them input a new number or you increment your counter. What is a nested loop? That's just a loop within a loop. Let's do a loop within a loop in order to print out a multiplication table. Multiplying all the numbers between 1 and 5. Something like that. So a nested loop is a loop within a loop. And so to do our multiplication table, we want to print out an entire row of numbers. So that's a for loop. And then hit enter, and then print out another row of letters. And hit enter and print out another row of letters. So there's going to be a loop that, for row equals 1 to 10. And then there's going to be a column loop that's nested inside it. For column equals 1 to 10, whatever. So it'll print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 because the inner loop has to execute completely before the outer loop can increment once. So we're going to print all the items in the column and then go to the next line. Our outer loop then increments 1. And then we go back into the inner loop and it has to complete. Print all the items in that row, all the columns in that row, and then come back out and go down to another row. So the inner loop finishes completely, or the body of the inner loop finishes completely before the outer loop iterates once. Hope that kind of makes sense. We'll give ourselves an example. For row in range, we're starting at 0 and we're going to count up to 5, so I want a 6 here. And I want it stepping by 1 each time. And then for column in range, same thing. 0 to 6, stepping by 1 each time. And just for now, before we get this working, here's what I'm going to make it look like. Print a star followed by a T, /T, a \T, the one above the enter key. And then underneath here, print done. But this isn't good enough because it's going to print, every print statement goes to the next line. And our row is going to have multiple items, so we don't want to go to the next line each time. So we're going to add an end parameter to our print statement. So after that, \T end quote, before the close parentheses, put comma, end equals quote, quote, something like that. And heck, maybe we could have put our /T here. I'm going to do that. I'm going to move the /T there and take it out of there. So every time you hit the end of our particular piece of data, hit the tab key. That's what we're telling it. Instead of hitting the enter key to go to the next line, every time we print an item in one of the columns, hit the tab key. But now we need to go to the next line, right? Once we finish the inner loop and we've printed all the data in that row, we finally need to hit the enter key and go to the next line. So back tab so that we're inside the outer loop, but we're outside the inner loop. Print, nothing. Just go to the next line. Now this should print something with 5 asterisks, 5 columns, and 5 rows, because that's the way we've set up the counters. It's not actually printing the data yet, but we're going to replace that asterisk with something that's actually good in a minute. I haven't saved my file yet, so This is lecture S. And there we go. Except it's 6. Well, that's all right. 0 through 5. That'll be a good math table, right? So let's change those to actual numbers. This, if this was a 0, 0, 0, right? 0 times 0, 0. 1, 2, 3, 4, 5. That's how I want that to look. 1, 2, 3, 4, 5. I might get rid of the zeros. The zeros confuse me on a math table how to accomplish them. I might change my range statement to say 1, 6. But then, you know, this is going to be the value of 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times 5, 1 times 6, 2 times 1, 2 times 2, 2 times 3, 2 times 4, all the way out to 6 times 6, or 5 by 5, or whatever the last place is going to be. Once we make this change, it's only going to be 5 rows and 5 columns. So I'm going to change that range from 0, 6 to 1, 6. And I'm going to change our data now. We don't need to print out asterisks. We want to actually print out the value. So that's going to be the row times the column. And there we go. Right? There's our little multiplication table. 2 times 2 is 4. 4 times 5 is 20. 3 times 5 is 15, right? 2 times 4 is 8, and so on. So the inner loop had to execute all the way, printing out every item in the row. Once the inner loop was done, the outer loop could iterate once, and it would go to the next line. And we see that. We're printing out all the numbers, every column. Once we're done printing out every column in that row, finally we can go to the next line, and the outer loop executes one tick. Iterates once. All right, and so a silly test question or mind tap question is the bodies of the inner loop can overlap. True, false? That's absolutely false because the body of the inner loop has to finish running before it can do the outer loop once. So that's a false statement. If you ever see the term inner, outer loop, and overlap in a question on my exam or mind tab, it's just false because it can't. The inner loop has to complete completely before the outer loop can iterate one more time. We are done with this chapter. Maybe there's another page of summary. All right. Common mistakes, neglecting to initialize the loop control variable. You've probably seen me do this. I start to write a while loop. It is supposed to be creating a total. And then I go, oh yeah, we need a total variable. And so I go back up a couple lines and I say total is equal to 0. Neglecting to alter the loop control variable. That gives you your infinite loop. A lot of the flowcharts did not have the line complete equals true, or success equals true, or whatever. And so it would loop forever if we implemented that flowchart in code, because we weren't altering the loop control variable. Using the wrong comparison. Well, yeah, if you have the wrong comparison, it's not going to work. If you're checking to see if x is greater than 10 and you meant to see if x is less than 10, it's not going to work right. And including statements inside the loop that belong outside the loop. We have a great example of that just sitting here. What if this was tabbed over once? Like that. Now, this line is inside the loop, inside this loop, and it should not have been. And don't make that change because it's wrong. Watch what it does. Prints out every number plus per line. We no longer have a multiplication chart because it's printing that character term every single time. We could kind of prove that to ourselves if instead of just printing out something like that, a little blank, we put a period there to show what we were seeing, right? It was printing out a number and then it was going to the next line. Printing out a number and going to the next line. Just because that last print statement was inside a loop when it should have been outside it. So I need to back tab that. And there, now we see that since this is outside of the inner loop, It does the inner loop. Once the inner loop is done, then it can print that and iterate the outer loop. Most computer languages support a for loop. Use the for loop to step through a series of values, 1 through 10, 10 through 100, or elements in an array. I want to print out all the test scores. In a post-test loop, which we don't have, the body executes before the test. The other loops, the test executes before the body. You can use loops to accumulate totals. I want to calculate the average income of all the families in this zip code. So you open the database, you keep reading elements from the database, you keep creating your total gets larger and larger. Once you no longer have any families in that zip code, then you print the total. You can also use them to re-prompt the user for valid data. You entered in, there is no student with that ID. That is not a possible temperature. Element not found, right? Stuff like that. Now this doesn't sound like anything that has to do with loops at all. But in a selection structure, the logical paths join together. Does that have anything to do with loops? No. But that's our selection structure, and the things have to join together after their paths are done. And I hate to say this, but if you use an elif there, then it's correct to have this go all the way down to the bottom like that. But I tried to write our code so it did not use elif just for that purpose, because it made the flow charting harder, or a little bit non-standard. And we are done with the chapter. Are there any questions over the homework? I don't know if y'all got a chance to look at the homework stuff that was graded over the weekend, but lots of good stuff. In a couple of cases, people turned in code that didn't run anything, meaning it was all comments, or that it was the program description without any code, or it had syntax errors, in which case you don't get any credit for it. Don't get mad, just revise it and resubmit it. Yes, sir?
The homework you're referring to is the revised pay calculator? Is that the one?
I haven't graded that one yet. I don't think. That was a recent one, right?
Yes, sir.
Yeah. If you have any questions over it, though, that's perfectly fine to ask questions over it, even though it hasn't been graded yet.
No, I was still working on it, but, no. I did want to if we could take a look at your notes from what you were just doing. I did.
Oh, yeah, I can bring the notes back up. That part or scrolling up? Okay.
So when it says 4 and then 4 again, that's the nested portion that we're talking about as far as a nested 4?
Exactly. And it could have been a while, and a while, or a 4 and a while, but this 4 is inside that, it's nested inside that. Just like the yolk of the egg is nested inside the shell of the egg. So if you were going to flow chart it, you'd have a diamond, and then it would go off to the right, and then there'd be another diamond. And then go off to the right again to actually have the body of the loop. That's probably worth doing. This flowchart will not take long. So as the last thing we're going to do in Chapter 5, let's go ahead and flowchart this nested loop. Very short loop. Right, it's going to have a diamond here, it's going to have a diamond there, it's going to have an output statement, another output statement. So it's only going to be 5 blocks, not counting the ovals. So go ahead and crank up Lucidchart. What is this? All right, it's just a... That is not valid programming logic. Why do I say that? Because we have an if statement that goes 3 different ways. The only way you could do that is with a switch case statement. you have multiple branches, a whole bunch of branches meeting in one place, so that's not a programming flowchart. So this is a nested loop example. And I just grabbed that by grabbing the T and dragging it out. So they all start with a start. This one has a for loop. To make it more interesting to diagram, maybe I should have made it a while, but like I said, for loops are so much easier to code. So we're just going to do for, why not just type the Python code? For x in range 1, 6, 1, right? Does a C++ programmer want to see that much syntax in there? Nah, but too bad. We're drawing this for our own purposes at this point. So now we're going to jet off to another loop. For, except it wasn't x, was it? What was our outer loop controlling? A variable called what?
Was it column or what?
The outer loop, the top for statement. If I go back and look, it was row. Yeah, okay. So for row in range 1, 6. And this one is for column in range 1, 6, 1. And so the line that was indented inside the for loop, this inner for loop, was a print statement, right, like that. I'm not going to specify too much about this end stuff, but I'm just going to put output for print row times column here. So we're going to come out here. Yes, bless you. We're going to go over here and do output or print output row star column. And then we're going to draw a line going back to the for loop, however you like doing that. I like doing it like that. And then, what was outside of the innermost loop? What was the next statement, the unindented statement outside the inner loop? It was a print, go to the next line. I'm going to just say print line feed, or new line. Maybe I'll change it to output because the other one was output. Be slightly consistent. And then this one needs to go back to the outer loop. And then we drop down to the stop. Now if I wanted to, I can make this look prettier. What do I mean by that? I could try to stick it so like the code look kind of like that. Code look kind of like that. Do you have to do this? No. Does moving the lines around make it very annoying to try to accomplish? Yeah, it certainly can. I'm going to go ahead and try it. You don't have to do it. The flowchart was adequate as it was. But I'm trying to make the logic absolutely perfectly clear about what I meant by nested. Right? And you can see that the inner loop has to complete all of the columns before the outer loop can execute one more time. That's why I drew it like that. In general, the only time I start jutting off to the right is when the code is indented. after an if statement, or a while, or a for. And I know folks have been drawing, multiple input statements going off to the right, and logically that's not wrong, but format-wise, I think the flowchart becomes easier to understand and visualize if you only jut off to the right when the code is being indented. Now that can kind of become a little bit of a problem if you have an if statement and it needs both sides, right? A yes and a no. It's a dual outcome, dual alternative, if, dual alternative selection. Because obviously you don't unindent on the else clause. But anyways, hopefully that makes it look good. Hopefully you see what I mean about a nested loop. If it was a nested while loop, you'd probably have something setting up. You'd have to initialize the loop control variable outside the while loop. And inside the loop, there better be some kind of update for the loop control variable. So if we wanted to rewrite our multiplication table to use while loops, we could do that. Not gonna. But above the diamond here, we'd put a while, we'd initialize row to 1. And then inside here, we would update row plus equals 1. And then above this one, right here, we'd initialize column to 1. And then inside here, we would update column plus equals 1. Moving on. Don't think we're going to have homework based from today. We'll see about that. And since we're done with Chapter 6, you ought to go and do the MindTap quiz for Chapter 6 if you haven't already done so. 5. Since we're done with Chapter 5, you're going to want to do the MindTap for Chapter 5. All right, arrays. What is an array? Well, here they're calling it a list. It's a series of values. It's not just one value, right? We've had name. Name is equal to Joe. Age is equal to 18. That's just one value. But it could be a series. It is a series. It's a series, a list of names, a list of ages. And so all the variables have to share the same name and have the same data type. What does that mean? Let's see if we can rewrite that kind of definition in professor speak. An array is a series of values with one variable name that are of the same type. So you could have an array, or let's just do examples. Array called ages. Every age is an int. An array called names. Every name is a string. And we could come up with other examples, right? Test scores. Which could be an array of floats, so on. I'm going to show you the syntax for declaring an array in another language besides Python. If you want an array of ages, you might do something like this. That would create an array of 6 integers stored in a variable called ages. And now, out in memory, we have a room for 6 integers to be entered. Yes, sir?
Is that word time, is that supposed to be type or?
Yeah, why'd I write time? All right. Yeah, that's supposed to be type. I apologize. Thank you.
No problem.
Go back up and modify that. That did not make a lick of sense the way it was written. All right, that's how you do it in one language. In another language, it might look like this. Int age is 6. Now that's shorter, right? It's just saying, okay, I need space for 6 elements. I'm going to put a comment that this is like Java style and that this is C style. Do you need to memorize those? No, not till you take the language. Here's how you do it in Python. Ages equals 6 times square brace 0 in square brace. Weird syntax, but not that weird. We're going to have 6 integers in our array, initialized to 0. How about names? Names is equal to, we want 10. 10 times square, quote, quote, in square. An array of 10 strings. That's just in this language. Every language is different. So since Python supports lists and not arrays, I need to tell you the difference between an array and a list. But we will use Python to simulate lists. Lists are more powerful than arrays. Now we'll describe why here. Arrays, technically, in computer speak, are fixed in length. Meaning that once I declare this array to be 10 elements long, it's 10 elements long. I'm not going to be able to append an 11th item to it. If we have 6 ages here, we're not going to be able to delete one from the middle and make it 5 ages. So arrays are fixed in length. Once declared, you can't append. You cannot append or delete items. It always has to be 6 long or 10 long or whatever we declared it to. Now lists are not fixed in length. Once declared, you can append and delete all you want. You can declare an empty list and then just start adding to it. Very common way of handling it in Python. Create an empty list and then just start appending. I'm going to change the word add to append because that's the name of the function we use. So instead of start adding to it, I'm going to change it to start appending to it. All right. Now here's the key, is that Python only has lists, not arrays. But everything you can do with an array, you can do with a list. So that's okay. It's just that lists have more functionality. So sometimes I will call them arrays. Sometimes I will call them lists. Just know that we're using those terms interchangeably. But for languages that support arrays, like C, C++, and Java, the terms are very different. It's just that Python doesn't have arrays. And conceptually, we need to know about arrays, so I'm not going to just teach to what a list is. The book hardly talks about lists. The book talks about arrays. It's one of the fundamental concepts of programming. I think I've said that if you get the idea of loops and functions, you're a programmer. Well, if you get the idea of loops, functions, and arrays, then you're a good programmer, right? Kind of adding on to our little list of things that we have to know to be programmers, but arrays are the third little pillar there. All right, so let's demonstrate an array using that first syntax. I'm going to create an array of strings, maybe just 4. I don't want to go overboard. So names equals 4 star open square, quote, quote, close square. And let's print the names array out. Print names. And we're going to see that it's got 4 blanks ready to be filled in. there we go. We've got our 4 blanks waiting to be filled in. Well, let's stick some data in it. Arrays are accessed by their index number, also known as subscript. Those two terms are pretty much interchangeable. I will use one, then the other. I will usually say subscript when I'm typing code in. And when I say subscript, think square brace. So something like this. Names, subscript 0 in subscript equals, quote, Alice. That's our first name in the list. Now I'm going to add 3 more names. Name subscript 1 is equal to, quote, Brenda, end quote. It's funny how names go out of fashion, right? People use the term Karen kind of dismissively, right? Like, yeah, you're just a Becky or a Brenda or a Karen, right? In the past, those were perfectly good names. Now, a few parents are using them. All right. Carol is going to be our 3rd name. Now notice I said 3rd name, but I typed subscript 2. That's because it's 0-based indexing. We start counting at 0. That's why we add a homework 0. And a name subscript 3, the last one, the 4th name in the list, is Diane. Now let's print the names out again. Print parentheses, names in parentheses. And I'm going to go back and I'm going to add some comments. This is where we declare our array. Set the first element. You could say item. The techie name is element. Set the first element. And so on. I'm not going to add every comment for set the 2nd element, set the 3rd element, and set the 4th element. But let's add a comment down here. Notice that the first element is subscript 0. And the last element is subscript 3. Or I will say the 4th element. Should have gone to 5 so I could say the 5th element. I remember that movie. The 4th element is subscript 3. So technically, if you have an array that's in items long, we're going to talk like math majors now. If it's in items long, you can access elements 0 to n-1. Since this is 4 items long, we can access elements 0 to 3. If your array is in items long, you can access subscripts 0 to n-1. There is a shortcut syntax called initializing your array, or giving it an initializer. And this is how you almost always do it in Python. Doing it this way and then adding 4 items takes 5 lines of code. We could do it like this. Colors, I'm just coming up with a different name for a different array, equals square brace, quote, red, end quote, comma, orange, end quote, comma, yellow, end quote, comma, green, end quote. That's about enough to prove the point, right? We did the same thing with 1 line of code. If I can get away with it, if it's appropriate, I would rather do it that way. Sometimes you can't do it that way, right? If we're asking for input, if we're asking for the names, then we're not going to be able to initialize it. We don't magically know in advance what names the user is going to give us. So this is using an initializer list to create, and now we're going to use that awesome computer language we're so fond of, to create and populate, parentheses, fill, in parentheses, the array. That's what that is an example of. And And I think we're done. We don't need any homework on this. We haven't talked about lists quite enough for me to spring another homework on you. Plus gives y'all time to catch up, right? I want 3/4 of the class to be making A's and B's rather than half. Heck, I'll give you all A's and B's if you earn it. That's my goal. All right, there is a Dropbox S. We really haven't done much code that could have syntax errors, but that doesn't mean you don't have any. So I'll do a walkabout. Well, I guess I never ran mine to make sure it worked. I could have printed out those colors, right? I could add one more print statement. Tell you what, one more line of code to add to it if you have not already. For S space IN space colors colon print parentheses S. That is printing out the array with a loop, with a for loop, rather than just printing them all out at once. Right? If we just do print and then give it an array name, it puts it in that funky syntax with the square braces and everything separated by commas. You're not going to really do that very often. Instead, you're probably going to use some kind of for loop or while loop to print it. And what this says is for every color that is in the colors array, print it out. Like that. And it printed out red, orange, yellow, and green. So my comment here would be that this prints out each color, one per line, using a for loop. Much more important to know this, much more common to do this than just print parentheses array name. Alrighty, guys. We'll have a little bit of time to hang out before we need to run out. Seems like we don't have a class that comes in after us. I keep checking this. Let's see, we're supposed to, so I don't know where they are. Anyways, we have a little bit of time.